Alrighty, so moving forward in Unit 2, we're going to start off by reviewing arithmetic and geometric sequences. So like we said in class, a sequence is a function from the whole numbers, so that's going to be our domain. Our domain is only whole numbers to the real numbers. To the real numbers. And that's going to be our range. This means that we are only able to plug in whole numbers, 0, 1, 2, 3, into the sequence, but we can get any real numbers as outputs. So because of that, because we can only plug in whole numbers, when we graph a sequence, we will have points, but we cannot connect them together to form a line because we're not going to be plugging in anything that is between 1 and 2 or between 2 and 3. We're only going to be plugging in 1, 2, 3, and 4. So let's consider the following sequence, and let's find a sub 1 and a sub 7. So a sub 1 is going to be equal to 4 times 1 minus 3, which is 1. A sub 7 is equal to 4 times 7 minus 3, which is 25. So a sub 7 is basically the 7th term in the sequence, and you just plug that in, and it tells you that the 7th term in the sequence is going to be 25 based on this. So in this course, we're going to be studying two important types of sequences. You have your arithmetic, which is going to be considered our linear sequence, and our geometric, which is going to look like an exponential sequence. So successive terms have common differences. So once you plug in your whole numbers 0, 1, 2, 3, the outputs have a common difference or a constant rate of change, aka the same slope, which is why it looks a little bit more linear. So formulas and equations, there's two different formulas that we use for arithmetic sequences. I will be sticking with this one. And the only reason is that this one right here, you have to know the initial value. And if you don't know what the initial value of the sequence is, what the first number in that sequence is, you're not going to be able to solve for it easily. Instead, I'm going to be using this one, which allows you to know any value. We're going to call this the kth term of the sequence. So it could be the 5th term, the 6th term, the 8th term, the 25th term, it doesn't matter. And of course, with arithmetic sequences, you have a common D, aka the common difference, which we will start noticing is also known as our slope. One thing I want you guys to spot about this equation is that it looks like a point-slope equation, point-slope form, right? Where D is the slope, n minus k represents the x's, and a of n and a of k represent the y's. Arithmetic sequences behave like linear functions, except they are not continuous because remember we said that we would not be connecting the points. Increasing arithmetic sequences increase equally each step, so the slope will always stay the same. So in this case, the slope is 3. So if you're making your table of values for n and for a sub n, so when n is 0, because we can only plug in whole numbers starting at 0, your a sub n is 1. When n is 1, your a sub n is going to be 4. When n is 2, your a sub n is going to be 7. And you see why I cannot connect these points, okay? I can't do this. And the reason is because the domain is only whole numbers. I'm not going to be plugging in 0.5 or 1.5 or 2.5 to figure out what those values are. So in example 2, like we did in class, determine if the sequence could be arithmetic. If yes, identify the common difference. So just by looking at this is actually a quadratic function. So right away, I know this is not arithmetic. But just to show why it's not arithmetic, you can show that there is no common difference by plugging in some values, 0, 1, 2, and 3, and you will get -3, -2, 1, and 6. And you notice that from here to here, this is +1. From here to here, though, this is going to be a +3. And from here to here, this is a +5. So why is it not arithmetic? Because there is no common difference. So just by looking at this one, I'm going to say, yes, it is. Okay, to prove it, you can show in the table. 0, 1, 2, 3. When you plug in those few values, you get 6, 4, 2, 0. And you notice that the common difference is -2 in each one. So why is this arithmetic? Because the common difference is -2. And you can kind of see the common difference. Because remember, the common difference is a linear behavior, and therefore the common difference will be the slope if given an equation. So what about if you're given that sequence as a set of numbers? Well, you have to check if there is going to be a common difference. And going from -7 to -2 is +5. Going from -2 to +3 is +5, +5, +5. So this is why the common difference is 5. This next one, hopefully you can see that it's not. Why? No common difference. All right, moving forward to writing the expression for a sub n given some values. So in this case, let a sub n be the arithmetic sequence. So I know that I'm going to be using the point slope form formula. And a sub 3 is 8, and d is -3. Find the expression for a sub n and then use it, to find a sub 12. So let's go back and let's remember our formula. A sub n is equal to a sub k plus d times n minus k. So a sub n is equal to a sub k plus d n minus k. Well, in this case, they're giving us this piece of information right here. This is telling you that the k, right, or the kth term that we are focusing on is this a sub 3. So a sub k is going to be whatever a sub 3 is. And that's going to be 8. The d is going to be -3. The n, just like in point slope form, this n stays n, and this a sub n stays a sub n, and we're going to plug in our values. So if a sub k is 8, what is k? K is going to be 3. K is that 3 right over there. So let's plug in everything that we know. So a sub k is 8 plus our d, which is -3, times n minus k, which is the third term. And you simplify this. So a sub n is equal to 8 minus 3, n minus 3. You can keep going or you can keep it just like this, but a sub n is equal to 8 minus 3n plus 9. And then final answer is going to be a sub n is equal to 17 minus 3n. So that is the expression given for the arithmetic sequence given this information. And then part 2 of this question said, well, now that you have an expression, find a of 12. So that's going to be 17 minus 3 times 12. And you do the math, you got 17 minus 36 equals negative 19. All right, let's keep going. So a of n, let a of n be the arithmetic sequence with a of 2 equaling 7. And a of 6 is equaling 9. So here they're not giving us a common difference, but they're giving us 2 points. Or 2 points on the graph. They're saying that when k is equal to 2, a of k, should have wrote that bigger, is equal to 7. And then the other point that they are actually giving us is the other x and y, which is n, when n is equal to 6, a of n is equal to 9. Because here they're not giving us a common difference. They're giving us 2 points and no slope. So we have to solve for the slope. We have to solve for the slope and then figure out our a of 10 term. So remember the formula is a of n is equal to a of k plus d n minus k. So here we're given a of n, we're given a of k, we're given n, and we're given k. So a of n was 9 equals a of k, which is 7, plus d, I don't know, and n minus k is 6 minus 2. Solve for d. Okay, so 9 minus 7 is 2. 4d, divide by 4. So d is equal to 1/2. So now that I have my d term, I can use my k term, right? A of n is equal to 7 plus 1/2 n minus 7. Why did I put 7? That's a 2. N minus 2, right? Because k is 2. And solve it. So a of n is equal to 1/2 n minus 1 plus 7. 1/2 n minus 1 plus 7 is plus 6. And now that I have my expression, what is a of 24? And you should get 18. So example 5, they're basically giving you the exact same information from example 3 and 4. They're giving you the point, but they're also giving you the common difference or the slope, right? So they're giving you the common difference and they're giving you either 2 points or the common difference and 1 point. So I'm going to use this point right here. I'm going to use that a of 1 is equal to 6, right? And then based on this, I'm going to figure out what my common difference is. Well, my common difference over here, looking at this graph, is down 2, right? Rise -2, run 1. So rise over run. So my common difference is -2. So I have my ace of 1, which is 6, and I have my common difference. So in my formula, they're telling you that this right here is your K value, and this guy is whatever your ace of K value is. So here we've got ace of K, which is 6, plus -2. Of course, I don't know why I keep doing that. You guys are juniors, right? You should know that it's -2, and then n minus 1. And that's my expression. I can simplify it if I need to or not. And from this expression, I'm going to use this to find ace of 17, which is 6 minus 2, 17 minus 1, equals times 17 minus 1. 6 minus 2 times 16. 2 times 16 is 30... 2 times 16 is 32. 6 minus 32 is -26. All right. The second part of these notes is about geometric sequences. Successive terms have a common ratio or a constant proportional change. So it's no longer a slope, but an exponential change. All right, so it's not adding or subtracting, you are multiplying or dividing to get to the next number. Again, same thing. I'm going to be sticking with this formula because this formula allows me to figure out the equation given any term in the sequence. I don't have to know the initial value. But once you simplify this, remember that the g of 0 is the initial value. R is the common ratio, and g of k is the kth term of the sequence. Now, geometric sequences behave like exponential functions, except, again, they are not continuous because we don't plug in the numbers between 0 and 1. Increasing geometric sequences increase by a larger amount each step. That's why it's considered an exponential. The percent increase always stays the same, but the change is different from step to step. So here, if we look at this guy right here, the number that is with the exponent, this right here is our common ratio, which is 1/2. So this tells me that each number is being multiplied by a half from one to the next. And then the 8 is my g of 0. It's the initial value. And we can see that if you make a table, so n and g of 0. So when n is 0, you plug that into the equation and you should get 8. When n is 1, plug it in, you get 4. When n is 2, plug it in, you get 2. When n is 3, plug it in, you get 1, and so on, right? And what you notice here is that each number is being multiplied by a half, or divided by 2, which is the same thing. But the common ratio is a multiplication factor, not a division number. So I'll let you guys fill in this this part of the graph based on these values, and you'll notice that it looks exponential, right? So it looks exponential. And this is an example of when you plug in 4, you get a half, right? So the range doesn't have to be whole numbers, but the domain does. All right, moving on. Example 6, for each of the following, determine if the sequence is could be geometric. So again, just by looking at this, this is not geometric because it's not exponential. So no. Okay, it's not. And you can show this by filling out a table and seeing that there's no common ratio. Looking at this one, this looks exponential. This is definitely exponential, so it is a yes. And I can see that the common ratio is 2. But you can check for yourself by making a table. All right, looking at this guy. All right, from 1 to 3, we're multiplying by 3. From 3 to 2, there's no multiplication, so no, this is not geometric. There's no common ratio. But looking at this one, to go from 16 to -8, we're multiplying by -1/2. To go from -8 to 4, we're multiplying by -1/2. To go from 4 to -2, we're multiplying by -1/2. So yes, and what is the common ratio? -1/2. All right, same types of problems. Let G of n be the geometric sequence, given G of 1 is 12 and R of 2. So looking at this equation, G of n is equal to G of k R to the n minus k. It's the same exact thing. This is G of k is equal to 12. And k is 1. And R is already given. R is 2. So let's plug that in. So given the common ratio and the G of k term, we can figure out that G of k is 12, R is 2, n minus 1. And that's it. That's all you have to do here. That is your expression for your geometric sequence. And then from that, to figure out what G of 4 is, you just plug in and solve. So 2 cubed is going to be 8. 12 times 8 is 96. All right, last problem is very similar to the one before, where they're not giving you R. So not given R, but you are given multiple points that you can possibly figure out what R is. Or you can just use two of the points and solve for R. Okay? So in this case, I know from G of 0 to G of 1, the change is from here to here. To go from 8 to 4, we are dividing by 2, correct? AKA multiplying by 1/2. Let's check if that's correct. To go from 4 to 2, we're multiplying by 1/2. To go from 2 to 1, we're multiplying by 1/2. So I see that R is 1/2. And then I can pick any of these numbers. But since I'm given the initial value, I could use the initial equation. The one that we talked about right here. Make my life a little bit easier. But again, I like to learn only one thing. Right? Not have to memorize many different types of formulas. So I'm going to use just the G of 1, which is 4. So here, G of k is 4, R is 1/2, and then n minus 1 because k is 1. And that is my expression. Now from this expression, if it's a multiple choice question, I can simplify this to 4 times 1/2 n divided by 1/2 to the 1, right? Because that's the properties of exponents. And 1/2 to the 1 is just 1/2. 4 divided by 1/2 is going to be 8. And that's going to be 8 to the 1/2 n. So these two are the same. Just one is simplified and using the initial value. And then from this, why don't you guys go ahead and solve for g of 10. All right, enjoy.